So this is going to be a fun interview.
Absolutely, looking forward to it.
Hey. And who are you?
My name is Chandrakant Patel. I've been at HP for 21 years. I started actually in Silicon Valley 25 years ago, designing disk drives when manufacturing was right next door. And then seeing that disk drives will commoditize, I went into...
25 years ago, when was that?
Do you know that my new rule is that the virtual age is equal to the current age minus 20?
Yeah. Let's see, that was...
83.
83.
Yeah.
I was graduating from high school.
I get that a lot. But like I said, the new virtual age is 20 years.
I worked in one of these buildings
is that right?
in '79 when they had an assembly line here.
Oh, is that right?
And I worked on a soldering machine, a wave soldering machine.
Yeah, that must be the surface mount line.
Yeah.
And there was building 5 that did microwave, millimeter waves. You know, the what was the Stanford Park division.
Yeah.
In building 6, and then there was a SMT line.
It's
Design
great,
and manufacturing might come back.
Yeah.
And some of the things we are working on may lead us to that. And so, you know, interestingly, I started 25 years ago. It's very interesting if you look at the history. I went from there to work on chips. At that time, we were working on the new microprocessor architecture to replace RISC.
Yeah.
And so I joined the research team here in Palo Alto. And then it was increasingly apparent that chips are going to come from 2 places, or maybe 3 places, standardized.
Intel, AMD.
Standardized set of places.
And where else?
Somewhere else. So it was time to move. And I moved into systems, and then I started to look at thermomechanical design and cooling of systems. Then I felt, you know, systems are going to be commodity, and I came up with the mantra, data center is the computer. The walls are akin to the walls of an enclosure, and the data center needs an operating system. So data center is the computer, it needs an operating system, and management of energy as a key resource will be a requirement in the data center.
Yeah.
So with that, we came up with this notion of smart data center, which led to this data center we are sitting close to.
And our microphones might be picking it up, but there's a data center literally 20 feet from us.
Exactly.
And so what is HP doing with data center? Because I don't think of HP as a data center company, right?
Well, if you look at it, and it's interesting to see where we are now, right? Data centers, and I'll get back to data centers in terms of, so then it was 98 was about data center, and now in 2008, we're saying it's not the data center either. It's the ecosystem.
Yeah.
It's the IT ecosystem made up of billions of handhelds, thousands of data centers, millions of printers, and thousands of print factory. How do we take this IT ecosystem and create next generation of cities where IT becomes embedded in the city such that we have a net positive impact on the environment? So why is this ecosystem important? Because we believe that we can use this ecosystem to reduce the amount of available energy used by the world. So today our shift has occurred from data center to ecosystem, where we are covering the range on how do we use this ecosystem to deconstruct conventional business models and replace it with an IT model. So why is data center important? When I go to India, I make reservations on Indian Railways, which has a great web presence, from my home in San Francisco.
Yep.
Why shouldn't the 700 million in India not be able to do the same thing? They should be able to access the same service using their handhelds rather than get in a rickshaw, go to the train station, get the ticket. It's a fundamental need. If we can provide IT services such that we negate the need to get in the rickshaw and go, we would improve their quality of life and reduce the amount of energy used. So the reason data centers are important are they are becoming the hub, and Web 2.0 is going to be addressing the fundamental needs of the society.
Yeah.
So when we put our sustainability hat on, I see the world as thousands of data centers with billions of handhelds, which will actually reduce the consumption of available energy.
Yeah.
So we think of, you know, I made a sketch here. If you think of the available energy as a pool of energy we have, the conventional ecosystem is using up energy. How do we use the IT ecosystem to reduce the overall consumption of energy? And studies have shown that the carbon emission from the IT ecosystem is 2%, whereas from the conventional ecosystem is 98%.
Yeah. Certainly if somebody has to get on a motorbike and travel to the train station instead of using their handheld, they're polluting a lot more and in a lot dirtier way, right?
Exactly.
Because even a so-called dirty coal plant can be scrubbed and can be cleaned before it gets its emission thrown out to the air. I've been over to China, for instance, and they use these little two-stroke motorbikes, and they're absolutely disgusting what they throw into the air, right?
So, and that's one thing, clearly from a pollution point of view. The second is the amount of energy consumed in the transaction is going to be a lot lower than traveling.
Yeah.
So how do we deconstruct other models? So another thing I often hear is there are lots of supermarkets opening up in India. There are lots of micro businesses. The micro businesses are going to want to compete, and they want to use IT services in their supply chain.
Yeah.
So it becomes a competitive effort for the ordinary people as well to improve their quality of life. So I believe that IT services will lead us to sustainable ecosystem if the problem is the 700 million are not getting on our bus, the IT bus, because the bus is very expensive. The ticket to ride is too high.
Yeah, you need a $300 set
$80,
handheld. Or
$80. I asked them, they say, 4,000 rupees, $100. They want a $100 handheld, and they want IT services $1 a month. So the total cost of ownership of the data center must be reduced. So one thing is data centers are going to be there to provide service. To reach and grow the company and have a net positive impact, we need to lower the TCO. And our work in the last 10 years has shown without a doubt that the total cost of ownership is driven by energy consumption.
Yeah.
So therefore, reducing the energy footprint of the data center is critical.
How much do you think you can reduce the energy consumption of a data center?
By half.
How are you going to do that?
It's twofold. One is, as I will show you in the tour later, the data centers have energy consumed by the machines and energy consumed by the cooling resources.
Yeah.
So by using sensing and control and scaling the cooling based on the need, we reduce the consumption of energy.
So you don't cool the whole room? You cool only
as needed.
As needed. Can you actually control where the cooling goes to each machine? Or?
So there is 3 levels of control.
Okay.
One is we aggregate all the information and then control the speed of the fan and the supply temperature that's coming out of the air conditioner.
Right.
And the air can be controlled furthermore by having adjustable vent tiles in front of the racks that we will walk into.
Okay.
So by controlling...
But it's still not by machine, right?
Not by machine yet.
Okay.
In this room, what we will be showing is it is at a rack level is a better way to look at it.
Okay.
But if the rack goes from 10 kilowatts to 5 kilowatts, we will pick that up. It has that granularity.
Right.
So a 50% change in load will reflect in likewise change in cooling.
Now I've been in a Google data center and they don't have any boxes.
Yes.
Why do they do that?
So for them it's to use, it's a simplicity in design and reducing the cost.
Yeah.
So they to get a lowest cost infrastructure, that's a good way to do it. And it's a way to use less material in the data center.
Yeah.
So in our case, the way we have looked at it is a similar approach in one way, but the key thing is the highest amount of energy consumed in the lifetime of a server. And we tend to have an end-to-end view. How much energy was required to extract material? How much was it to manufacture the material? So bauxite to aluminum, then manufacture aluminum, build our boxes, and dispose of our boxes. In that overall cost, the operational cost in the data center from an energy point of view. So if you think of joules as the currency of the flat world, not dollars, rupees, or yuans, and you looked at the available energy used across the life cycle, in the case of a server, the largest amount of energy used is in operation. For every watt dissipated by the server, the cooling takes another watt without a control system. Your home is more sophisticated than a data center. Would you buy a ceiling fan without a knob?
No.
Data center, the air conditioners, most of them don't have knobs. They're running at full speed. Over-provisioned from a material point of view and over-provisioned from energy point of view. So how do we write provision? So in the case of operation, the way we look at it is we write provision by our mantra of need-based provisioning. Sense and provide just what you need.
Interesting.
So the cooling is the example of providing the right amount of cooling based on the need. But it just doesn't end there. Let's take the example of that person who is going to do reservations 5 years from now. His service level agreement does not call for the data center to be on all the time. The guy doesn't even have electricity at home.
Yeah.
So based on his service level agreement, can I provision a resource? Maybe a mobile processor. Why does he need a high performance processor? And maybe he doesn't need 6 nines. Why should I give him excessive redundancy? Data centers have a lot of redundancy.
Yeah.
The air conditioners are on standby redundant. So why don't I make right provision data center, provide the resources based on service level agreement, and not have excessive redundancy in the data center. So the key, the dream we have is based on that service level agreement of that individual. We will provide a computer at the right location, provide the right amount of coolant based on the need and the right amount of power. We will use virtualization as a knob and allocate workload based on the need. And we are experimenting with that in that data center. So that's the experimental data center where the work is going on in workload allocation.
Now, will this type of technology be used for an Amazon or a Google or a Microsoft,
Absolutely.
or will it only be used on smaller scale, kinds of data centers?
No, it can be used it scales very well. So in other words, after we built this data center, we had a lab, which is like a data center built in Bangalore, which is 70,000 square foot, 5 megawatts of power. We are using 7,500 sensors to control the air conditioning. And in a city like Bangalore, it's very critical. Energy, it's utility, we take for granted here. Their power may not be available. We have to use diesel, and we don't want to use that much diesel for obvious reasons, CO2 emission and also excessive energy consumption cost. So what
especially now, right?
Yeah, especially now. It's if
gallon of diesel is a lot more expensive than it was a year ago.
Exactly, and if you compute the cost based on that cost of diesel that you're talking about, the electricity would be 25 cents a kilowatt hour. Yeah. You are paying probably 8 or 10 at home. Yeah. So the payback is immense. So in that context, we have applied it in a large data center, and we have also applied it other places. So it's scalable. It goes to a large scale data center. So the cooling control system we have built. Now what we are saying is, let's also start to allocate workloads, and we are doing those experiments. We've got results. So when I take all that into account, providing the right amount of power to do the compute, providing the right amount of power to do the cooling, and also allocating workload based on the need, taking out redundancy, I can reduce that data center footprint by half easily. Yeah. And that's just in operation.
Do you think these techniques can be used in the home?
Absolutely.
Because my home is very much like a data center right now. You have to heat the whole thing or cool the whole thing, and I'm obviously in one room usually.
And your home is probably more sophisticated than a conventional data center. Like I said, in a conventional data center, unlike that data center, there is the air conditioners are controlled based on a sensor at the return. Your home, if you were in Texas, may have 3 zones, and you may be shutting one zone off and so on. Multi-zone is available in homes. So the question then becomes, why isn't this being done in the data center? Your home is a kilowatt, a data center is a megawatt. So in the limit, you'd need 1,000 zones. It becomes a very difficult problem. Can this apply in the zone? Absolutely. Can this apply at home? Absolutely, it applies at home. How? If you look at our architecture, we have said, let's build with flexible building blocks, put a pervasive sensing layer, and a policy-based control system. That architecture applies to home, it can apply to building, it can apply to auditorium, it can even apply to cities. The key thing is, when we design our systems, we need to design with flexibilities. You need to put the knobs in place that I can turn. Yeah. And then I can apply a control system. Yeah. So this is a very scalable model across the ecosystem.
In terms of sustainable IT ecosystems, I know my sponsor is Seagate, and I know you guys buy a lot of Seagate drives. And Google
I used to work in disk drives.
Yeah, and disk drives fail.
Yes.
We all know they do. And other things in the data center fail. How are you working to make sure that you can swap out and recycle that stuff?
Excellent. Because
these things, like Google has, some people think they have 500,000 computers, right? That's if those computers only last 2 or 3 years, that's a lot of equipment that has to go into the dump, right?
I'm very excited you asked the question, because I have maintained that the throwaway attitude that we have had cannot sustain. So when we go and buy a drive at Costco or something, and you see a terabyte for $300, you say, oh, it's a very low cost drive. But what if I told you that I'm going to charge you take back for all the aluminum that was used in the disk drive, the amount of energy that was used to extract the base plate? We are getting to a world where we'll have to do end-to-end accounting. When we do end-to-end accounting, to your point, absolutely to your point, there is gross over-provisioning in the data center. More drives are used than are necessary. Why is that the case? It's because people are trying to make up for reliability, or over-provisioning just to be on the safe side. So what are we doing? The way we are doing it is, if you look at the sensors we have used them for control. Now why can't I use that sensor to extrapolate the core temperature of the disk drive? Based on the core temperature of the disk drive, can I determine the temperature that the lubricant is running at? Based on the temperature of the lubricant, can I extrapolate how long the disk drive will survive?
Yeah.
We have not got to this root cause analysis. We have to apply knowledge discovery and analytics to right provision rather than just over provision and swap out drive.
Yeah.
So in this end-to-end view, and to your point, if we could do that, so we have predictive maintenance and make the drives last longer, we will win from an end-of-life perspective,
Yeah.
and we will end from extraction perspective. So what has been missing so far, so when you ask the question, how can you save, and I said 50% in operation of the data center,
Yeah.
that was correct, but we can still go more. The place we can go more is by minimizing the material used in the data center. So that goes to the heart of this thing. How do I make my disk drives last longer? And be very holistic. So people say, what if I replace rigid drives with solid state? They will use less power. But the power density will be so high that we may have to use more cooling power for the same
Yes.
thing. So we need to look at how much cooling power will be used. Then there is other question. One of
And
the
also they might not last as long, at least right now, right?
yeah, and
The read-write cycles might not be as high.
and how we would have to look at how much energy was required to extract the material that was used to build those. So, intuitively some things are correct, but we need to have methodologies that do end-to-end analysis to say that, yeah, intuition in this case does say that a move towards this kind of a configuration would be lower energy footprint. So if you go back to the joules currency, use joules, unit of energy as a currency, and you go to a least joules method,
Yeah.
from an end-to-end perspective, and use that as the currency, that's maybe one way of building the ecosystem. Maybe there's other ways to build the ecosystem. One of the things I often asked is, there's a lot of copper in the data center.
Yeah.
So my colleague Stan Williams, the brilliant nanotechnologist here, his lab is working on replacing the copper with
Yes.
photonics.
Yep.
So
We just talked to them.
he just talked to them, right?
Yeah.
So here is a way in labs where we are combining the theme across variety of labs to address sustainability. So I would work with Stan to get rid of copper. But I think I really like your drive question. This tells we need to go back to engineering. When I designed drives back in '83, we had manufacturing next door. We understood. As we got to mass drive design, I might say that we thought of them as black boxes.
Yeah.
And we measured external temperature. And we just looked at them as failures which are low cost that we could just replace. That cannot sustain. We have to go back to engineering products so that from a sustainability point of view, we manage end of life. And I think that's where we are going to tend towards. We are going to tend back towards that kind of engineering.
So it sounds like, because I'm going to meet with Seagate this week, you want them to know what their real cost to you is,
Exactly.
so that you can report that to your customer. Hey, this drive costs not just this much to buy, but this much in energy and this much in environmental impact, and it's recyclable, and this is what it's going to cost
Right.
to recycle it.
Yeah, and by the way, they have done a phenomenal job. I mean, I am so proud of what drive industry has done. In '83, I was working on a 1 gigabyte drive the size of a washing machine.
Yeah.
And you look at what engineers have done.
Yeah.
They have brought technology to the masses, and disk drive is a prime example. So they've done a phenomenal job in drive design. What the next step is how do I extrapolate the information such that I can make the drive last longer.
Yeah.
And by the way, there is plenty of business. My vision is that the IT ecosystem will become such an integral part of the city. So if we were designing the next generation of Palo Alto, IT may be so embedded in it that we will have lots of drives everywhere.
Yeah.
So
And screens and printers.
and so the volumes are going to be there. In fact, if anything, they're going to grow as we deconstruct conventional business models and replace with IT. The thing we do is, as this volume is going to grow, how do we make IT itself sustainable? It is not sufficient to say that IT is low. The same intuition that we were saying earlier. It's not sufficient to say that IT by itself is lower energy. We got to make it lower energy from an end-to-end viewpoint.
Yeah.
And I think, and I had when I worked on drives, I also worked with Seagate on many of the 40 megabyte drive at that time.
Wow.
Enjoyed it. The kind of technology that goes is phenomenal, and the fact that they are still around. In '83, I was told that, by the way, bubble memory will replace all mechanical drives. And here we are, 25 years later,
Yeah.
and the state of art is being still pushed. All we need to do now is less material, less energy, appropriate material.
Well, thank you so much.